Good morning. Today we're going to continue to work with systems of linear equations, or linear systems for short. We're going to continue to try to solve these linear systems, or in other words, try to find the common solution, the values for x and y, that would work in both equations that we have in our linear system. And again, we're going to keep looking at two different methods that we have to solve those linear systems. The first method being substitution, and the second method being elimination. In this video, we're going to focus on objective 2, how we can analyze or look at linear systems and figure out which method, substitution or elimination, is going to be the most efficient or the easiest method for us to use and arrive at the correct answer. For our example, we're going to look at two different linear systems. On the left, we see our first linear system in blue, and on the right, we see our second linear system in red. We're going to first look at the blue linear system, with our question being, which method would be most efficient for me to use in solving this linear system? Take a second, pause the video, look at the blue equations, and try to figure out for these two linear equations what would be the best way to solve that linear system. Welcome back. Hopefully you realize that substitution would be the best way to solve this blue linear system. I recognize that substitution would help me here because the first equation is built for substitution. It already has the y, one of the variables, isolated or all by itself. Since I know what y is equal to, that would allow me to substitute into the other equation and replace the y with something that involves x's and numbers and could be used to solve the equation. By using substitution, I could take that second equation, take the y, and replace it with the expression that the first equation told me is equivalent to y, 2x minus 4. In doing so, I've now created an equation that has all x's. I've transformed this from a two-variable equation to a one-variable equation. We could solve for x. Once we work out and figure out what x is, we could then solve for y. Now, we'll ask you to take a look at the red linear system and think to yourself, if I were asked to solve this system, what would be the most efficient method for me to use? Pause the video, take a few seconds, and figure out which method you would want to use here. Welcome back. Hopefully, you decided that elimination would be the best method to solve this linear system. Here is why I would use elimination. First off, neither equation is built for substitution. When we looked at the blue linear system and it said y equals 2x minus 4, I had one equation that already told me something that was equal to y that I could plug into this other equation. Here, neither equation is solved for y or solved for x. This y is multiplied with 5 and also has a negative 3x on its side. This y is multiplied with negative 2 and has a positive 3x on that side of the equation. What I do see is that the x's coefficient in the first equation is negative 3, which is the inverse of the coefficient for the other x, a positive 3. And I know that when I combine two inverse terms, a negative 3 and a positive 3, they're going to eliminate each other. That's why I want to use elimination here. I want to go ahead and add up both equations that are provided for us here. When I add those equations, I need to make sure to add the terms on the left with only terms from the left, and keep all of the right terms on the right side and only adding with each other. I have to follow my rules with like terms, so this 5y could only be added with other y's, or in this case added with a negative 2y. That's going to provide us with 3y. And the main reason we wanted to combine these two equations is that the negative 3x and the positive 3x are going to eliminate each other. Cancel out. That removes all of the x's from my equation. When I combine a positive 4 with a negative 6 to get to negative 12, I now have transformed this into an equation with only one variable that could be used to solve for y. Once we do figure out what y is, we can then plug that value back into an original equation to try and figure out what the x needs to be as well.